we've introduced MCP as a way of interacting with IP Fabric as a platform. What it wanted to do initially was really to talk through a couple of things. So let's give you the agenda for what we're going to talk through today. So the first thing is really to understand, well, what is it that IP Fabric's doing and why it's interesting to what you do as a network practitioner, and then really step into why AI is important in that and what additional capability it brings as a result. So once you have this understanding of what the network is, why is MCP important? So I wanted to cover those first, and then what we're going to do is just drop through a couple of use cases. Really, we've got these 3 threads that I've chosen here, really based on things that are important for a network practitioner to do as part of the day-to-day job. So the ones I've picked specifically, you can see here, design validation. This is really about saying, is the network built the way I expect it to be and doing what I want it to be doing? You could equally say that's around plan change as well, and being able to understand, right, is the result of my change what I need it to be? The second thread really is root cause analysis, and this is kind of almost the exact opposite of that. This is taking the symptoms of some change in the network and working out what has changed and why it changed. Very, very detailed, potentially, analysis required there. The third one is looking at something that's really not practically possible right now, but what we want to be able to do is probe at that a little bit and see if there are ways that we can really help predict the way the network will behave under certain conditions. And so the what if scenario becomes a thing. And then obviously at the end here, we'll just chat through what's next for 2 different sets of people. We know that there are going to be existing IP Fabric customers on the call who want to know more, but there are also going to be potentially people who haven't yet used IP Fabric. And so we want to give you some guidance as well as to what comes next. But let's just briefly explain about the point of the digital twin. I suppose when you're going through any network operations process, anything where you're looking after a network infrastructure, there are certain things that need to be delivered, and it all hinges really on this first point here: understanding how the network infrastructure supports your business. So it's being able to understand the impact that issues, when they arise, can have on business process. And it's really, I suppose, mapping through those dependencies from different parts of the network on each other, but also on applications and how they sit on the network infrastructure. So typically that's in people's heads, or really a tribal knowledge that's been arrived at through experience in an organization. And what we want to do is see where we can help with that. That spills down really into these other 4 areas I've listed here. There are lots of others, but things like reacting to unplanned change, so resolving incidents that have occurred by being able to diagnose them, and so as a result, minimizing the outage time, I guess, for any of the services that run across the network, and of course the number of outages as well, because you're proactively able to see what's going on. The idea of plan change, where you're having to prepare and consider what a change is going to consist of, to validate that it's been completed correctly, and of course to look after the rollback or fix forward approach that you take as a result of that, not necessarily doing what you need it to do. So much understanding of the network is needed in that process, and again, so much of that is embedded in people's heads. Exposing that in a more programmatically available way, a key to automation and potentially to agentic approaches as well. Project control here, this is about measuring and demonstrating progress. So this is about saying, how do I demonstrate that things have changed and these changes have been positive, not to just the network operations folks, but people outside that. make sure that the CXOs see what progress is being made and how much better things are than they have been, or see where the critical pinch points are in the network and so on, so that investment can be made to fix those things. All about having a full understanding and of being able to demonstrate that that you know and understand where the network needs to be improved. So it is really about that measurement piece. And then obviously the last one is a really simple sort of one. In reality, it's about lifecycle management. It's about having control, that day-to-day control of the network infrastructure itself, really understanding what it is, where it is, what state it's in, and how it needs to change going forward. So these are all areas that you need that understanding for. And of course, this is where the digital twin really comes in, because it can help you address all of those things. So what does that mean? Well, from the UI of IP Fabric, for example, you now have that ability to interactively observe the network. You have that ground truth. The data model that sits under in the platform gives you that data and gives you the starting point for all of those things we talked about. You've got a single place to go to understand how all of the network hangs together and interacts with each other to deliver service. Great for the individual who needs to use that as within the line of their work. But then we need to take that beyond that, because obviously that's fine when you've got sufficient individuals to do that work. Where you want to share that out or make it repeatable or automated, you need to be able to appreciate there are data points in IP Fabric and any other digital twin that you can pull those data out and then use them programmatically. Once you've built the scripting or whatever workflow, it's then available for others to use. So you're not then relying on the one person's head. And I guess the point with MCP is we're taking that step further. We're not just saying you need to know where all those data points are, because the LLM that uses MCP can reason about that. It can make those decisions for itself, decide what information it needs in order to do the correlation that it needs to do, to build the narratives that it's about to share with others. And so as a result, you're creating something that's much deeper, potentially from an analysis point of view, or much more diverse in terms of where it's gathering data from, and then is able to present that in a way that's consumable by a much broader audience. That's really where MCP comes in. And from an IP Fabric perspective, this is kind of how it all hangs together. So at the bottom of our iceberg, we have, deep in the depths, we have that network infrastructure that's unfathomable really to many. It's dark, it's complex, and it's hard to understand. And so IP Fabric comes along and creates this data model based on that network infrastructure that then becomes a little more structured, a bit more normalized, a bit more manageable. IP Fabric's API on top of that data model makes that now accessible. So the UI, you can interact with it. The API, you can make it programmatically available. But now by placing the MCP server, this control layer on top of that, what that now does is opens that up to whoever is interested in network information to be able to conversationally pull that data through IP Fabric's API and present it outwards. So as IP Fabric is the digital twin for this, MCP becomes the interface into the LLM, which is where that reasoning is going to happen, where that correlation is going to happen, and of course where that hallucination has the potential to happen. But the key here is that IP Fabric's data is deterministic and bounded. And so as a result, you're going to get definitive answers to questions. And so there is no need for the LLM to hallucinate about that data when it has the definitive view. So hold on to that thought. So let's drop into the first of the demo use cases, and this is something that certainly something I've stumbled across many times in my role as a network consultant over the years. This idea of checking and to make sure that the network, as it's implemented, is as it was originally designed. And that can be, like I say, full network design, or it can be down to the individual changes. IP Fabric will support that through each of the modes that we've talked about. From a UI perspective, you could just drop into the product, go look at the topology information that comes back, look at the technology tables, and ensure that those match what's in the design document. You can check then by creating intent checks on configuration to make sure that things are configured as they should be. But this is all down to the individual interacting with the product to do that. The next step up from that would then perhaps be to use the API to script those exceptions. So to look to see, right, okay, so this configuration isn't as it should be. How do I go fix that? And then build that into, for example, Ansible playbook or something to go remediate that based on inventory data that's pulled from IP Fabric. You might also choose to take that verified data and push it into other systems where it's useful. This is where the API really would be used in that case. It's about ensuring that everything is consistent with that design and with the network as implemented. So what does the MCP bring that's different? Well, what it's going to do is take that whole step further. It's going to be able to produce a report and a remediation plan using those original source materials and best practices that is going to be consumable by the wider audience. So it could be another network engineer, it could be management, it could be whoever needs change management folk, or whoever needs to understand that the network actually reflects what has been documented. I'll give you a quick example. If you're a network engineer like I was, you'll recognize this instantly as the kinds of documents that we use to build our networks from. There's information in here about this document would have been put together by an architect to include inventory, connectivity information, configuration information, control plane, management plane, all of those good things. And if I scroll these through, there's my diagram. Here's my inventory of devices and the versions of code that I want to run on them. Here's my connectivity matrix, which interfaces are connected to which. Here's how span entry is going to be configured, what IP addressing I'm using, and so on and so forth, right? So there's plenty of information here about how that network is wanting to be set up and built. And this would be a very typical way of that being captured as a Word document with a bunch of tables in here with all the information that you need. Now, that is great, but obviously, if we're then going to go and look at IP Fabric, let's say, to see how that maps to the network as it's been discovered, we can see, obviously, the diagram looks like the diagram that was in the product there. We can go into our technology tables and we can look at things like connectivity matrices, and in particular that was for the Paris site. So let's focus that down onto Paris. We can see the information here that matches the information in that design document, but it might be in a slightly different form, and it might not necessarily be exactly the same. And so we have to sit as an individual and do some translation between the two. We might also decide, right, actually, I need to decide in the product where things match the standards I have and where they don't. And in this case, we've got NTP sources here. You'll see this red and green color coding over here. This is basically my NTP sources are set the way I want them to be. This is my rule that I've created. And essentially, I'm filtering this list here. I might choose to only show the red devices, and then I might decide, right, these ones I want to go and remediate in some shape or form. So I could do that manually by looking at these, or if I should so choose, I could go through here, prod that API endpoint with this payload and get that result to then allow me to automate that process. So this is all about making sure I've got the right data in the right place in order to automate this. But I have to know which data it is that I'm looking for. That's critical to this. So to go to my next stage, to use my MCP, and what I've done here is I've used Claude Desktop. You could use any of the other platforms, but Claude will help give us an indication of exactly what's possible. We've used the Sonnet 4.6 model because it's a good model for this kind of thing. Your mileage may vary depending on which models you use and on which agents, but this gives us a good example. Now, and what I've done here is I've basically said to Claude, take that LLD document that we were just looking at, the Word document, and using IP Fabric's snapshot, validate that low-level design has been implemented correctly. I've asked it to look specifically at a few things. You'll see topology, VLAN, spanning tree, so on in there. But essentially, it's going to just do that comparison for us. Now, we're not scripting this. We're not telling IP Fabric Claude to look at specific IP Fabric API endpoints or specific pieces of data. It's purely going to use that document to determine where to go look. And so what it's going to do here is, using the MCP server, it's going to prod the API of IP Fabric to essentially bring out a load of data. And this was a really quick one. And what it's done is it's looked at VRRP, OSPF, spanning tree, BGP, NTP, syslog, SMP, all of these things, and assembled a group of findings. And I've asked it to basically write that out to a validation report. So if I just click through here, scroll it to the top, you'll see what it's done. It's created a summary and said, look, there's some deviations, there's some areas where we conform to everything, and then we go into it in a bit more detail. You can start to see, right, yeah, actually I've got things that are conforming here or in terms of my physical connectivity, but some of my OSPF tables are wrong. Now, this is just pointing out that actually there's inconsistencies between the tables in the document, but it's been able to do that for us as well. There's some issues around some of the interfaces have been swapped around in the tables, but now we start to get into the interesting things. Spanning tree, you can see we've got a root bridge placed badly here and needs fixing. And as well as being able to spot that problem, what it's also been able to do is give us the configuration that needs to be deployed and where to in order to fix the issue. Now, for all the will in the world, you're not going to automate this simply through being able to pick these kinds of things up, unless you've got essentially template configuration for every platform and every condition, every technology that you're deploying. What using the LLM has done here is opened up the door here to, because IP Fabric is a vendor agnostic model, we store things in that way. Well, you can use the LLM here to essentially work out how to apply the data that comes from that vendor neutral model to a specific vendor environment. And we'll see that as we step through this further. So these, in this case, there's some configuration for a couple of Arista boxes here that's needed in order to bring our spanning tree in line. Our IP addressing looks okay according to this, but VRRP is broken. So again, we've got some remediation configuration to deploy there. What else have we got in here? We've got some issues around OSPF on Cisco. So this is now Cisco iOS configuration in terms of the costs there, and some Junos configuration as well here. So by using the LLM, it's able to apply the right remediation for the right platform. And you'll see that, yeah, we've done our BGP checks as well, all good. Some more stuff down here around NTP, and this comes back to what we were just looking at in IP Fabric. Basically, there's a remediation activity here for certain devices where it's not got an explicit NTP server defined. There's the Arista EOS command line, there's the Cisco ISXE command line in order to deliver that. And so on and so forth. We could go step through each one of these. But in reality, what you're going to get is this report that tells you the things that are right and the things that are wrong. And of course, what that can now be done is shared with project managers, with network managers, with whoever needs to know in order to see progress. So because you can run this now, and then you can run it tomorrow on the next snapshot of IP Fabric, and so on and so forth, to see how progress is being made. Okay, let's go to our second example, and this one is an interesting one. This is root cause analysis, and this kind of turns the whole thing on its head, because this is now not going to IP Fabric and looking for this specifically for the data, but looking really at where things have changed and why. So it's the symptom rather than the actual state configuration. So in this case, in the UI, it's all about going to look at our path lookup capability and our snapshot comparisons to say, look, something's changed. Where is it? What is it? And how do I find out what it is? As an individual, I'm doing the exploring, but IP Fabric's giving me the tools to do that. From an API point of view, we can take the endpoints that we find in the UI there and script it. So again, we can look at a specific path, show how it's changed between snapshots by scripting the analysis of that JSON output that comes back from those API endpoints. But again, it's very, very specific, very narrow focused. As soon as we introduce the MCP, it can broaden that analysis and deepen it, because it can now look at, well, actually, it's not just about the fact that the state has changed, but we need to understand why it's changed, what from a network perspective would have caused that to have happened, and really brings then a different level of analysis, the sorts of things you would get from that sort of senior engineer. So again, let's have a quick look at what that actually means. Let's start with looking at IP Fabric again. And in this case, what we've got here, we've got a traffic flow between an on-prem device in this Prague location at the top left, going down to this AWS environment in the bottom right here, and it traverses a number of stages in the network, goes through the MPLS network here, through the Boston location, over a VPN, and going out into the wider network. You'll see firewalls shown here in green, which is all good. It means the policy is allowing that traffic to pass. And so as a result, we're able to hit the load balancers that we're seeing down in the bottom right here in AWS in order to reach the destinations we're looking for. So that was then, but what happened overnight? Because this is what this looks like after a change. Prague is still where we start, obviously, but now we're traversing into Paris, and then via a firewall in Paris out to AWS. Well, the AWS doesn't seem to have changed, but our firewall is now showing red, which means that traffic is blocked and isn't going to work anymore. So here's our issue. Something broke overnight. Something has caused the traffic to change direction, go through Paris. What's happened? Now, in IP Fabric itself, what we can do is we can do this comparison of snapshots. I'm looking at day 4, I'll compare it with day 1, and we'll see what's happened. And you can see very clearly where that change has occurred. Going through Prague, I reach this router, and where before I used to go this way, now I go this way. So I could start by digging into that router, exploring the behavior. And if I just take one of these, you can see the routing decision that's been taken and the routes that it's used. And now I can look at more detail at the routing table, the ARP table, the MAC table, and so on. So it's giving me all the data as an individual practitioner that I need to go and work this out. It's also, of course, again, we're able to extract that information through the API. So I can use the API to extract the information about that path lookup and go and make more sense of it. Or I can ask Claude to help me. So let's switch back to Claude. And let's look at our second scenario here. And basically what I've said is, look, Claude, do me a favor. Using the day 1 snapshot, list out the path between those two endpoints, using TCP 443. So that's working out, is this traffic going to be able to get from here to here using that port list? And you can see there that it's built the path through, and it's showing all the elements, the on-prem, the MPLS, and so on through AWS. And then what I've done is I've asked it, actually, can you now look at day 4 and see what the difference is. And you'll notice here it's highlighted some things in the middle. It's a different path out of Prague via Paris in order to get to AWS. So now I need to understand, well, why has that happened? There's some sort of migration event that it's talked about in here. You'll see the on-prem WAN path has changed. You'll see the IPsec VPN pointer has now shifted as well, but the AWS path itself is unchanged. So what is that migration? What does it look like? And it's saying here, the pivot point here is the Prague router. In day 1, it forwards towards MPLS. In day 2, it forwards towards Edge 2X01. Well, what's Edge 2X01? Well, as we look further down, it works it out, right? Same. That's a Cisco SD-WAN environment. So the migration appears to be from MPLS to SD-WAN. Awesome. It's really working this through nicely. But it's also talked about this cloud breakout anchor site changing. This is the VPN tunnel that was in Boston that's now in Paris. So what's happened there? And as you scroll down through here, it basically points out that in day 1, you were receiving essentially a summary route via the path in through Boston. And now what we're seeing is this new path, this new VPN tunnel, which is giving me specific routes from AWS via the new endpoint. And as a result, you can see that the traffic is shifting there as well. So rather than go into it in any more gory detail here, with the thing I've said, look, create me a report. Let's get to the bottom of this. And this is the report that it's created. And essentially the overview is this. There's a path lookup investigation. The results are these. This is the before, this is the after, this is the summary of the path differences. So how the path has changed. This is the AWS side. This is the SD-WAN stuff that we're now using, the protocol shifts and so on. These are the prefixes. And as a result of that, the interpretation is this. And that can now be presented to someone who can just pick this up, consume it, and understand exactly what's happened, whether that's an incident manager, whether that's the network management people, whether it's the people who are looking at the results of a change. In a meaningful way, what the MCP has provided is all of the IP fabric data to back up this root cause analysis investigation. The data's there if you were to do this as an individual, but because the LLM is able to do this, we can also then go ahead and use the data from IP fabric for that as well. So appreciate I'm running out of time already here. So let's quickly dash on to the third use case that I've got listed here, and this is the legend that is the what if scenario. It's probably the question that everybody wants to be able to ask. We know how difficult what if scenarios are, particularly in real networks, because you've got such a variety of technologies that it's really hard to emulate those. You have to divide and conquer your network into separate pieces in order to be sure that you've got an understanding of that centralized and distributed control plane and the data planes and policy planes and the behaviors of those things. So really, if you're wanting to do this end to end, the real solution here is not to try and emulate at all. It's a really tough thing to try and do. It's computationally intractable. It's just such a big challenge. So it's much more sensible to reason probabilistically about this. It's the way that you or I would, as a network practitioner, if we were asked to try and determine what would happen, we would sit down and we would think about it and weigh up the probabilities. What IP Fabric is bringing to this is that determinism. It's saying this is what the network looks like and this is how it behaves right now. You can trust that the data represents the way that the network behaves. What the LLM will bring is this reasoning capability on top of that to say, well, actually, I know and understand what these technologies do and the interactions between them, assuming you're using the right models. Is what's going to happen? Let's think about it. Let's correlate the data. Let's reason over it and give you an answer. So let me very quickly show you my final example. So here we have, in our demo environment, we have this Frankfurt location, which is, as you can see, there's a whole mesh of interconnection here using different protocols, a whole bunch of different protocols, relationships between these devices, both control plane and data plane. And while it's self-contained, it's also obviously connected through this firewall out into the wide area network. So the first thing I asked Claude in this case was, well, what actually is that location? You know, go look at the at Frankfurt site in that snapshot, see if you can work out more about what that location is. And so what it's done is it's created its own topology view, its own understanding, and it's tried to, using the protocols it can see, characterize the behavior of that network. And it can see that there's OSPF running, which is essential for the for an underlay environment. It can see BGP running over the top of that, and it can see VXLAN being used to carry data from layer 2 VLANs over VNIs to the other VTEPs across that. And so it's rightly saying, look, this is a modern spine leaf data center fabric using VXLAN, using IBGP for EVPN, and essentially then routing via a checkpoint firewall out into the wide area network. So what I've then asked it to do is map a path between two locations across that fabric and out into the wider network, which it's gone ahead and done, and understands what that means in terms of encapsulation and decapsulation and so on as it's coming into and out of the fabric. Again, we can share all of these outputs. Actually, they might be useful to you to look through in detail. But then what I've asked it to do is do a switch by switch failure analysis. Look at the individual switches in that fabric and look at the impact that they'll have on that traffic path. Now, in this particular case, it's clear switch 1 and switch 5 are important to this. Switch 5 being the top of rack host, where the host lives. The switch 1 being the spine switch that this traffic is passing through by default. And obviously, initially, if you lose that switch, it will break the path. But then what happens? And so I've asked it to then go to that next level. If that switch were to go down or the interface go down, what happens next? And as a result, it then looks, right, sees OSPF will do its thing. And the underlay, it will reconverge. And as a result, we'll be able to still maintain connectivity and so on. So it's gradually iterating away on the behavior of this network to understand exactly what's going to happen. You can see here it's talking in detail about the different OSPF adjacencies, about the way that the VLANs are interconnected with the VNIs and using VXLAN and so on. And then then I've asked it specifically, right, we'll look at the underlay routing and make sure that everything as it should be. And again, it goes into much more detail here about how OSPF inter-area routing is working, what changes happen when interfaces drop, and so on. So many different things it's pointing out as it goes through, and it's really trying to work this out in detail. You can see here there's reference at the bottom here about there's a genuine routing reconvergence, not instantaneous ECMP rehash. This isn't a simple superficial view of what's going on there. And so now we arrive at what really is the end point here. There's single points of failure that it's identified. There's issues here with how this is deployed. And what I've asked it to do again is basically write that out as a markdown file, as a report, and you can now step through that in the gory detail that we've talked about. But it really here, it's basically got a series of recommendations about how to fix this. So dual homing, firewall clustering, but also adding additional uplinks into the fabric where there are the things missing. So it's really about getting to the bottom of the problem. something that probably wouldn't have been easy or particularly straightforward to have done by without having all of this data available. And I guess this is kind of the point here. So I think we'll park the demo piece there. There is essentially the next steps if you're an IP Fabric customer are to go ahead, upgrade to the latest version of IP Fabric, accept terms and conditions, enable the server, and away you go. Really, it's then about setting up your client to refer to that. Plenty of information in the documentation and plenty of support from our solution architects to help you get there. We're really keen to help you break open these new capabilities that you haven't had available to you before. For those who are not yet IP Fabric customers, well, you know where to go. I mean, the website has got plenty of A, information, but B, means by which you can come talk to us and start to talk about free trials and POCs and those good things. So, but yeah, hopefully that's give you a bit of an idea about what the capability brings. Anyway. I'm just looking. I think we may be onto our Q&A. I think that's probably the best thing to do next.
I think that's
Maddie, you're back.
Hey, yeah. And it seems like we've got a couple questions coming in, especially in the last few minutes. But just to start off with kind of a broad question first.
Sure.
You were using Claude throughout these demos.
Yeah.
But can you use your own custom LLM with this MCP server? And is there anything you should do differently if you are using a custom LLM?
Yeah, no, that's a great question. Yeah, as you say, we use Claude for the demos primarily because the data is all demo environments and labs, and so from that perspective, there was a lot of experimentation going on, right? We also found that the models, the Anthropic models in particular, are very effective and very well trained in network. In network process, so they have will reach a really good answer. That said, we have already got customers who have gone ahead and enabled this in their environments and are using it against private LLMs in their own pods, using the open source LLMs, and are getting good results. As I said before, your results will vary, based on the models you're using and the training that's been done on them. But ultimately, with the right prompts, you are going to get really strong results and address use cases you wouldn't have been able to before. Great question.
Yeah, and we have even more coming in. I'm just going to take in the order in which they were received. The next one is also pretty general, but how does IP Fabric handle security for the MCP server?
Okay, yeah. So the security is really important, actually. When you go back to that the iceberg slide, because the MCP server is literally built on top of the API, we essentially use the same authentication that we use for the API in order to get access to data. So you provide an API token as part of your MCP client setup, and it will always use that same API token to access the data, which means that when you define RBAC, the role-based access control for that API token, you're able to limit or basically place the controls around the data that's accessible through MCP. So yeah, it's a really good question.
Awesome. All right, the next one's from Normand, and he's asking, does the MCP server expose config management endpoints or just the devices and end-to-end paths and technology tables?
No, it's a really good question, Norman. Thank you. Yes, the config management endpoints are exposed. You can, for example, we've seen cases where customers have done CVE analysis using the publicly available CVE data, but then IP Fabric's configuration data to make sure that that devices are compliant or otherwise, right? So it's a great use case.
All right. The next one is, since IP Fabric now has MCP for LLM reasoning, are there plans to add Batfish-like formal validation, or is this outside the product scope?
Great question. Of course, while I work for the product organization, I probably can't talk in terms of formal roadmap, but I guess yes. So to your point, that whole what if scenario formal validation piece is important as a capability. I think for now it will continue to experiment using the LLM in order to deliver that, but I would never say never. That's probably the most I can do in terms of a commitment for you.
Never say never, indeed. All right, the last question for now, unless there's any more, this is maybe the last chance to ask any questions. What resources are necessary to implement an MCP server or a client server solution? Yeah.
That's a really good question as well. We've been very gosh, the team have been very, very thorough looking at the resource requirements and everything in here. What we have managed to do from an IP Fabric appliance standpoint is to keep the resource requirements the same for where we've added the MCP capability into the product. Essentially, from a memory perspective, from a CPU cycle perspective, from a storage perspective, there is no change. There is an embedded small model within the product now, which is used to essentially do the translation between the natural language query and the API endpoints at the back end in order to pull the correct data through. But that's already downloaded and distributed as part of the product. So there's no requirement, for example, to drop the air gap and connect to the internet if you don't need to. So basically, the short answer is there are no additional resources at this stage.
All right.
Great question. Thank you, Renata.
Yeah, so many really good ones. Thanks everyone for submitting your questions, for participating in the chat. Again, if anyone wants to take a look at our prompt library, it's free. It's linked in the chat. It's linked in the docs. If you have questions, feel free to reach out to the team. We'll be sending out a follow-up with the on-demand recording and stuff as well, if anyone wants it. Yeah, that's all from me. Thanks, everybody.
Yes, thanks very much. Thanks for your time.